Good morning, dear students. Today we will see unit number 2. Actually, if you see the syllabus of unit number 2, you can divide this syllabus in two parts. The first part is the FSM based design, means how to write an VHDL code for a FSM, that we have seen in an earlier lecture. And the second part is things which are related to the system on chip. You may call these things as a digital design issues. You also say that actually these are nothing but the topics which are associated with whenever you are going to fabricate a chip, whenever you are going to put your system on a chip. If you put your system on a chip, what are the different issues that you must consider? These are covered in unit number 2. Means unit number 2 has two parts. You understood that part. The first part is the VHDL code for FSM, that is a finite state machines, and how you will write these VHDL codes. And second part is you can give a single name, that is a system on chip. When you put something on a chip, quite obvious, there will be a certain issues related to the clock, related to the power, related to the IO architecture, or you may say pad design. That's why whatever the remaining part is over there, that remaining part covers all these things. In today's lecture, we will see the clock skew, what is the clock distribution, and the clock jitter. What is a skew? Clock skew. By definition, clock skew is a very simple thing, that is a clock reaching to the flip-flop at different times. Actually, it is expected that the clock must reach to the flip-flop at same time. This is a understanding part, that is what is a clock skew. Means whenever there are two different flip-flop or whatever may be the number of flip-flop in your circuit, it is expected that the clock should reach to the each flip-flop at the same time. If it is not reaching to the flip-flop at the same time, then quite obvious there is a skew. And definition is maximum difference in the arrival time of clock signal to any two latches or flip-flops fed by the network. Means whatever may be the your source of clock is over there, from that source the arrival time at the flip-flop, whatever may be the difference, is called as a skew. The skew are of two types, positive skew and negative skew. The diagram itself will explain you the positive skew. You can see that there is a more delay in flip-flop 2 as compared to flip-flop 1. And in negative skew, if you see carefully, there is a more delay in flip-flop 1 as compared to flip-flop 2. Now see positive skew. If the clock at capture flip-flop takes more time to reach as compared to the clock at launch flip-flop, then it refers as a positive clock skew. The clock at capture flip-flop take more time to reach as compared to the launch flip-flop is referred as a positive skew. Means can you identify out of these two flip-flop 1 and flip-flop 2, which is a capture, which is called as a capture and launch flip-flop? Can you identify it? If a clock at a capture flip-flop take more times, means definitely here, that's why initially I explained you that for a flip-flop 2, the clock will take more time. As a delay is more, means definitely the flip-flop 2 is what? a capture flip-flop in this case. Similarly, when the clock negative skew, when the clock at capture flip-flop take less time to reach as compared to the launch flip-flop, it will be a negative skew. Now you can see that the skew describes the relative delay or offset times between two signals. Skew causes problem. Actually, if a skew is over there, quite obvious, the flip-flop will not function properly. Flip-flop will not function properly and it may go into the metastability state. That's why whenever you are designing a circuit, you must design a circuit with a zero skew. It's not possible, but the skew should be as less as possible. The skew may be in between two data lines, a data signal and a clock, or between a clock signal in a multi-clocked system. Now, what are the sources of skew? Sources of skew means what? Why the skew is over there. Okay. It may arrive from an external source also. When a skew may arrive from external source, it may happen the skew may be because of the delay through the clock network. Okay, it is a delay through the clock network that may vary with the position on the chip. There may be certain qualified clocks may add a delay to some clock destinations. It may happen. There is another thing, that is a temperature variation. Actually, because of skew may be over there because of the temperature variation, because temperature dependency are over there on gate and buffer delay, because delay may changes because of change in temperature for a circuit or a buffer. For the buffer or an inverter, the delay changes as the temperature changes. Here there is some example. Okay, you can see that there is a certain arrangement of a clock distribution, and if you see the distribution, you will come to know that for the first two flip-flops the delay is 10 nanosecond, for seconds the delay is 20 nanosecond, and for the third the delay is 30 nanosecond. And quite obvious, this is the reason of the skew. The first two means you can say that in the first case the clock reaches at 10 nanosecond. For the second, it reaches another more 10 nanosecond. Okay, another more 10 nanosecond. This may be because of the length of the wire. It may happen because of the length of the wire. Now, quite obvious, we understood that the clock skew is a more problem. Clock skew is a more problem. Then to avoid that clock skew, we have to go for a clock distribution technique. Distribution technique means what? Whenever we are going to route a clock, at that time we will see that we will try to reduce the skew as low as possible. That's why there are different clock distribution technique. The main job of clock routing is to design is to control the clock skew from the clock pad to all the memory element, because we know that the memory elements are the flip-flop, and hence the clock must reach simultaneously to all the memory element. The major obstacle to the clock distribution is a capacitance, and with resistance playing a secondary but important role. Whenever you go for a clock distribution, quite obvious, when you have to route a wire, and if you route a wire, it will give capacitance as well as a resistance. Clocking is a floor planning problem because clock delays varies with position on the chip. There are multi-layered chips also, and in multi-layer chips you have to go for a floor planning, that what circuitry you are going to keep on a particular position. And in that case the delay varies. Delay definitely it will varies depending upon the floor to floor. Clock distribution network or a clock tree is the metal and buffer network that distribute the clock to all clocked element. Clock distribution technique means it is actually the metal and buffer network, and which is giving the clock to the all clocked element. And which are the clocked element? These are the flip-flop. These are the flip-flops. These flip-flops are over there, to which you have to provide the clock. Clock tree usually built by a clock tree synthesis tool. Actually there are the different softwares which will do this task automatically. Automatically means you may say that by the optimization method they will go for a better physical design or better distribution of the clock throughout the network. There are different techniques or there are different softwares which will do this task. Now whenever you go for there are two clock distribution, there are two styles of physical clock networks. Physical clock networks means it is actually built on a chip. It is actually built on a chip whenever you want to distribute a clock, and these techniques are H tree and balance tree. In the next video we will see what is H tree and what is a balance tree.